So thank you so much for inviting me for this session. So I have prepared a small session on 5G for smart utilities and smart cities. So before I start my presentation, let me introduce myself again. I am Ashok Kumar, Director Wireless Access at NTI PRIT. So NTI PRIT is a capacity building arm of DOT, Department of Telecom, and where we, train our own officials and also the ecosystem partners, and we also undertake international program of APT, ASEAN countries, etc., and we provide training and other capacity building program for them in physical mode, and since pandemic it is happening in online mode, and hopefully that will again start in a physical mode. So as we know that 5G is around the corner, our operators are testing. So we thought of starting capacity building onto the 5G domain. So last year in 2020, when pandemic was on peak and everyone was at home, so we designed a program called 5G certificate program. That was a 36-hour program to be delivered in 12 weeks time. So every week 3 hours, 3 days, 1 hour each. And we trained almost two batches of 70 75 personnel from DOT and other ministries twice, right? And we also have like we would be repeating this in this particular year also. So we are already doing some kind of capacity building on 5G domain. We also do lot many webinar on upcoming technologies. We do education and awareness for other ministry, which we did in a physical mode, one for joint secretary and above level officers on 5G and cyber security. And we have a plan to do it for more officers and also in the state government as NTI PRED. Uh, we are also trying to establish 5G lab. So the prime objective is, of course, the training of our officers and other government entity and other ecosystem partners. But that facility, we are also planning to give access to all the startup, all those companies who are doing use cases development. So going forward, once that is in place, we will also be facilitating our companies, our startup in developing and kind of innovating new and new use cases. So let me start my presentation with this remark. Okay. So we know that there are over 2 billion cellular IoT connections as of now today. So there are a lot of papers on it, and there are projections that it will increase to 5 billion connections by 2025. So there is a huge growth happening onto the cellular technologies for IoT. There are other technology like LoRaWAN, Sigfox, etc., Wi-Fi and all, but the cellular IoT is growing at a very, very faster rate, all because this is a kind of a unified technology which is a standard based. Whereas if you look at LoRaWAN, Sigfox, all those are proprietary one, but these will coexist definitely for a long period of time, and maybe the best technology will emerge as a winner, or many of the technology can coexist. So in my presentation today, I'll start from the basic that what are the various key capabilities of 5G which Tosniwal sir mentioned initially, and how those capabilities can become potential use cases for all sectors. And since this session is for smart utilities and smart cities, we'll focusing on that. And Tosniwal sir had already talked about EMBB, URLLC, and MLLC. So we'll look at specific features of these usage scenario and how that can translate into use cases, particularly in India. We will also talk about other cellular technology like NB-IoT and LTM. What is the roadmap? Because many of the power sector and smart cities actually deploying technologies based on NB-IoT or LTM. So what will happen to that after the 5G, whether they'll coexist, and how? And then what is the promise of 5GI, which our own TSDSI had developed, and that is now part of Release 17. And we'll also discuss the upcoming technologies or evolution in the 5G in terms of RedCap. What are the new use cases which it can take care of, and today which are kind of left out. And then the last I'll talk about how mobile infrastructure and power infrastructure can actually converge and help each other. So there has been some white paper around it. So we'll discuss about that at the end. Okay, so let's start with what are the different usage scenario of 5G. So in fact, for mobile technology or cellular technology, from the 3G onwards, ITU defines the vision and also the framework for those technologies, upcoming technology, and also define the performance requirement. So in 2015, ITU defined the vision for 5G. They call it IMT 2020. And as per their vision, there were three key usage scenarios. One was EMBB, Enhanced Mobile Broadband. Other was URLLC, Ultra Reliable Low Latency Communications. And the third was MMTC, Massive Mobile Type Communications. So when we say EMBB or URLLC or MMTC, these are not a specific service as such, but any use case or service will utilize some part of URLLC, some part of EMBB, and some part of MMTC. For example, if you talk about remote surgery or mission critical surgery, then it will be using majorly the URLLC capability, but it may also require EMBB. For example, if you have an autonomous car, so of course it will require URLLC capabilities, but since the car will also have uh, uh, various cameras looking at here and there, and also the entertainment system inside, so that will also require EMBB, and it will have a lot of sensors, right? So it will also use the MMTC capability of the 5G. Okay, so let's have a look at these capabilities. If you look at the EMBB, so what are the key capabilities of 5G which makes it different from the earlier technology? So it is EMBB. So in terms of peak data rate, if you look at the peak data rate which 5G can offer, in fact, it can go up to 20 Gbps, right? Which is kind of a 20 times better from the 4G. So if you have a very, very large volume of data to be transferred, so 5G will help in that, right? So it's a huge capacity one base station on one tower is about to give. And how it is being achieved is like there are various technology in terms of multiple frequency bands it support, in terms of higher channel bandwidth it support, and also the peak spectral efficiency which is it has 30 bit per second per hertz, which is three times better than 4G. So and the next, the capability of 5G related to EMBB is the user experience data rate. When I say user experience data rate, what I mean is that when you go onto the edge of a network, you should get some guaranteed speed. So that is defined as 100 megabit per second. For 4G, it was 10, it is 100. So that is a kind of a minimum guaranteed bit rate which you can get even onto the edge of a network. But of course, it will depend upon how much spectrum you have allocated to the operator. For example, if only 100 megahertz of the spectrum is allocated to operator, so with 30 bit per second per hertz spectral efficiency, it can achieve only 3 Gbps peak speed. So if one has to achieve 20 gigabit per second, so that means you have to give him minimum 700 megahertz of bandwidth, and that too in a different frequency band for different use cases, right? And the next important aspect is the mobility, because today lot many applications, be it drone, be it high speed train, where this 5G will be serving, will be running at a very, very high speed. So mobility supported in 5G is 500 kilometer per hour. So even a system like the high speed trains will be supported in 5G. So now coming to the next usage scenario, which is URLLC. So what are the important performance parameter of 5G before we talk about specific use cases in the field of smart cities and smart utilities? So the latency, the response time in 5G can be achieved up to 1 millisecond for the use cases of mission critical services, be it of smart city, be it of smart utilities. You can achieve 1 millisecond response time, if you compare the response time of our human eye, right? So if I throw something towards you, your eyes blink. So our latency or our response time of our eyes is about 250 millisecond, whereas the 5G network will support 1 millisecond of the latency using various techniques which it is deploying. Now, the next important parameter is the reliability. So, unless the network is reliable in terms of availability and also in terms of reliability, you cannot use for mission critical services. So, the reliability part, we say ultra reliability. If you look at 3GPP specification for mission critical services, the quality of service parameter, they support a bit rate of 10 to the power minus 6. That means if you translate that 10 to the power minus 6 of the bitrate tolerance, you will achieve about 99.999% of the reliability, which is very, very high compared to our earlier network or any other network. And of course, our applications would be getting signal, 5G new radio signal from various towers. And if the application is mobile in terms of say drone is mobile, your trains, vehicles are mobile, in those cases mobility interruption is 0 millisecond in case of 5G. That is what is the requirement which ITU had given. Now let's going to the third usage scenario, which is MMTC, that is massive machine type communication. So here comes the massive IoT sensor network which we talked about. So the most important parameter is the connection density. Now that every machine, every object, every device would be connected on 5G network going forward. So the density, connection density supported has to be very, very high. In case of 5G, it is 1 million device per square kilometer. So if you connect everything together, then also it will have a support because of this connection density. The other important aspect for a sensor network which is required in smart cities, smart utilities and all other sectors is the energy efficiency, because the sensors which are getting installed are maybe at very, very remote locations. You may not have opportunity to in fact charge the battery or replace the battery. So your battery life has to be 10 years, 15 years. So the network design has to be in a such that the energy consumption is very, very less, and 5G has done that. So if you look at energy efficiency of 5G, uh, towards network side and also towards the devices or sensor side, uh, it is 100 times more energy efficient than the earlier generation, that is 4G, right? So a lot of effort has gone into designing the 5G system so that it is energy efficient and your battery life can be achieved up to 10 years, 15 years. So that is very, very important. So now let us look at how 5G can support various IoT requirement in all the sectors, including smart cities and smart utilities. And so as we know that it will definitely support the massive IoT, and which is today, if you look at other technology, be it LoRaWAN, Sigfox, or NB-IoT, everything, all these technologies are actually supporting massive IoT, where you have requirement of dense connectivity, very less power consumption of the device, but data rate requirement is very, very low. Latency requirement is not very stringent. But when it comes to broadband IoT, where you require larger bandwidth, for example, if you have a surveillance camera, either monitoring the grid or monitoring the smart city or any other applications, so there you require broadband kind of. So here the role of 5G comes, that in addition to the massive IoT, it will also support the broadband kind of environment because of the capability which it has. Similarly, those applications which are very, very critical in nature, which requires URLLC kind of stringent requirement. So there comes the 5G, such IoT, critical IoT services you can also use on 5G, which was not possible on the traditional, the technical platform which we have. And of course, the industrial IoT, where a time sensitive network is very, very important. your precision location kind of capability is very very important, where 5G will actually help. So 5G is not only supporting the massive IoT which we are using today, but also broadband IoT, critical IoT, industrial IoT in a better way. And there are many technologies or kind of capability which 5G is building, which will support. For example, network slice is one of the aspect of 5G, wherein for requirement of a specific use case, be it for smart grid or smart city, or for any matter, you can create a logical slice, that is a kind of uh, dedicated network functions which will be supporting that kind of quality of service or latency or the guaranteed bit rate or any kind of other attribute which may be required. So those resources will be dedicated the network end to end. When I say network slice, it is from radio to the core to the other part of the services, including transmission. So you'll have a specific slice offering that service. So in case you have a critical IoT, you are dedicated with a network slice for that. If you are using broadband IoT, you have a different slice for that. So that, and the slices are isolated from each other. So security aspect is also taken care. If your application is security sensitive, so with slice you can kind of isolate it in a different uh, way. The one of the capability of 5G is the network exposure. When I say network exposure now, the suppose Mr. Satish was talking about the platform for IoT, right? So that platform can connect to the 5G network through the network exposure, just an API interconnection, and can gather a lot of information, because 5G would be capturing lot many data points, log and all, and those would be possible to be transferred to the platform, IoT platform, if some AI ML algorithm has to be run, and or network has to be managed, kind of, or there is a knock requirement of the data. In addition to that, the 5G has got a network function, native network function for data analytics. So all those logs which is coming from the IoT network, very, very large volume of data, big data, those can be analyzed within the 5G network and certain action taken. So that is a capability which will be very, very useful even for IoT. And then in 5G, we'll be supporting the flexible SIM, where either you have a physical separate SIM or embedded SIM or use SIM kind of environment.
Sorry to interrupt, Mr. Ashok. We have constraint of time, so kindly conclude in the next couple of minutes.
Yeah, so 5 minutes, is it okay? Okay, fine.
In the next 2 minutes.
Okay, fine. So as I discussed that the 5G is designed in a way that the technology like NB-IoT or LTM can coexist, right? Coexist in the sense that the investment which utilities have made, are they are not required to throw it out. They will continue for a very very long time, and then they can migrate to a 5G kind of environment wherever they require it. And I talked about 5GI. So 5GI is now part of release 17, and perhaps in the month of March and June it will be actually it is already approved, but now that will be formally approved by 3GPP. So once that is done, so 5GI was designed by TSDSI for a large coverage. So their large coverage requirement is for IoT. So it will further enhance the capability of 5G to support kind of environment. And the next item is the 5G RedCap in release 18. 3GPP is working on reduced capability of the 5G, so that so the other use cases like wearable, where you don't require very very high battery life, but you require some broadband capability. Similarly, surveillance, industrial IoT, and other applications which are in between the massive IoT and the capability which 5G NR have. For that, 3GPP is coming on the 5G RedCap. Now there is a new opportunity for the power sector, the transmission service operators or DSOs, distribution service operator. if they can work with the mobile network infrastructure. I'll just this is my last slide, so let me explain this. So the problem, so I'm not expert in the power sector, but whatever I have read, so the problem in the power sector or the grid network is about the frequency regulations. So if there is more demand or less demand, so your frequency 50 hertz or 60 hertz get disturbed. Similarly, when there are a peak demand where you're not able to meet the peak demand, or there is a high peak to average power ratio, that average you have a less power, but in the peak time you have a very requirement of very high power. And then you have a voltage stabilization issue where voltages are less because of all these aspects. How the mobile infrastructure can help power sector, and power sector can help mobile sector, by because the mobile network today is you have more than 7-8 lakhs of mobile towers located across the geography, and those are distributed as per the population, right? So wherever there is a power, there is a mobile tower also, right? So at the mobile tower they have power backup, right? And all these mobile networks are monitored centrally or at a regional basis. So for example, if there is a frequency, if the two converge, like mobile infrastructure and power infrastructure, what can happen is, if there is a problem towards the grid, now since these two are converged network, the mobile fellows can reduce power consumption by switching to the battery backup when there is a peak demand happening or voltage fluctuation happening, and that too in one local area or regional area or a national basis or a select basis, and the problem of the power sector can be taken care of. Similarly, since these mobile towers are located at every nook and corner, every point with the local grid, so that means they have ability to monitor the voltage fluctuation, monitor and also bringing that to a central location. That capability is already there. So this kind of data, if is utilized by the power sector, which mobile
Sir,
fellows are already
sir,
having. So this is my last second. And similarly, since these towers is having the battery capabilities, in case of a requirement, they can even release power to the grid. So and in return, all those infrastructure which power assets are there, TSP can utilize for a small cell, which will be a dense network, and TSP asset can be utilized by TSO DSO. So with that, I conclude my sessions. Thank you so much.
thank you, Mr. Ashok, for a very informative discussion. Uh, Now I invite Mr. Pradeep Hirasule, Product Development Manager from Reliance Jio.
Hello, everybody. Sorry.
Let me stop. Sorry. Yeah, thank you.
Not sure. Yeah. Hello, everybody. This is